Okay, third in the series of quadratic function transformations, um, and a graph of them, which are parabolas. We have f of x equals x squared as our parent function, we mentioned before, and there are different transformations we can use to create other graphs from that parent function. In this vlog, we're going to be talking about x minus h, the whole quantity squared. And how does that change the graph of the parent function? We've already seen transformations where the parabola goes up and down, or opens downward, opens upward, and even where the parabola becomes wider or thinner, skinnier. Now, this is a little different than the rest of the other ones because we have x minus h. That subtraction sign creates some issues, as you'll see. Okay, in this example, I use parentheses around this example. We have minus a positive 3. The parentheses in this example isn't really necessary, but I'm doing it to illustrate a point. It's going to be x minus 3, the whole quantity squared. So as you can see here, as we put the positive 3 and replace h with positive 3, what it looks like is x minus 3. It's really the opposite of what we put in there. Our next example is even more important as we see that. If we have h as a negative number, maybe negative 6, like we have here in this example, we'll see what happens. So now, h is like a box. It's placeholder. Wherever h is, we put in negative 6. We keep the subtraction sign, so we have x minus a negative 6. So the importance of parentheses becomes clearer here. We have minus a negative, and what happens is it becomes x plus 6, the whole quantity squared. So you can see where I highlighted the numbers here. I placed positive 3 in there, but it became x minus 3. You may confuse that with h being negative 3. As we discussed the formula, we have subtraction within there, x minus h. I replaced h with a negative 6, and it became x plus 6. So it can confuse some students. Okay? And we're going to discuss the graph right now, and I'll show you what happens as from the parent function f of x equals x squared to these quote-unquote children or children functions. So x minus h. x minus h quantity squared. It's going to move it left and right, and we'll see that in a minute. So as you see, our red graph right in front of us is the parent function, f of x equals x squared. The one below that, we have x minus parentheses negative 6, the whole quantity squared. I wanted to put that in there so it was clear you know what was going on. So the blue dotted line we see in front of us, it moved to the left 6 units. So the red is our parent function, 0, 0. The parabola moved over 6 units to the left. And it becomes negative 6, 0. Now we'll look at the graph x plus 6, the whole quantity squared. If you've been paying attention, you should know already what's going to happen here. So as you see, they're the same graph. The blue graph and the black graph. X plus 6 quantity squared. We have to think of that as x plus 6, but we're moving 6 units to the left. You know, I know we think of the x-axis. You move positive is right, negative is left. Well, this form is x minus h, so it reverses the direction. Now, the third and, well, actually the fourth one on our list here. One second. X minus parentheses 2, the whole quantity squared. And below that we have x minus 2 squared. They're the same graph. I just wanted to show that how it all works out. If I were to turn on the parent function, the red parabola here, the range is larger than 0, and the vertex is 0, 0. Now remember, h is, with this x minus 2 quantity squared, h is positive 2, right? The blue dotted line, h, remember, is positive 2 in this. It looks like x minus 2, but it's x minus a positive 2. So it moved 2 units to the right. And when I turned on the other graph, the purple graph, it was the same graph. The last one on the list, x minus 5 quantity squared. You should have a feeling of where this is going to go. Shift. It's not going to shift left, it's going to shift right 5 units. Now you can see the vertex. If you look at x minus something squared, you're going to move to the right because h is positive, moving h units to the right. If you see x plus something, we're moving to the left because h is actually a negative number. But it turns out to be x plus the number because of the subtraction. Now, we're going to look at all the parabolas. I'll click them all on and we'll look at the domain for all these parabolas. The domain for all these parabolas, what things I can use for my x value, is all real x's because every parabola just gets wider and wider and wider. Now the ranges for all these have the same range. From the x-axis and on up. There's no y values or possible answers for y below the x-axis. So it's y equals 0. We can have 1, 2, 3, 4, but there's no like y equals -1, y equals -2. There is none of that. There's no answer. There are no answers for y below 0. So it's 0 and above. So now, this is how we follow the formula function here. Now, x minus 2, the quantity squared, I move 2 to the right. It looks like minus 2, so left, right? But really, it's x minus a positive 2. H is positive 2. And the opposite situation, we have x plus 3 quantity squared. The graph is going to move 3 places to the left or right? Left. Because within the form of this, we have x minus a negative h, -3. So it's going to go 3 to the left. Okay.